right, kiddos, welcome to our discussion of liquids and solutions, at the PreAP chemistry level at Allen High School. We're going to jump into a practical example of these concepts that we've been talking about in terms of liquids, and then we'll be moving into our discussion of solutions. Now, when we talk about boiling point and elevation, that's a clear distinction, because at this point I'm talking about altitude. You'll understand why I want to make a distinction about that word elevation by the time we get to the end of the unit. So right now I'm talking about what happens as we change altitudes. Now, the normal boiling point, what we define as the normal boiling point of a substance, is the boiling point of that substance when the atmospheric pressure is 1 atmosphere. So that's how we come up with atmospheric pressure. The atmospheric pressure is defined as 1 atmosphere when we're at sea level. So it's kind of got a rather vague internal reference point there, as opposed to kilopascals, which are our SI units. Now remember, vapor pressure, when vapor pressure equals the pressure of the atmosphere, that's when a substance boils. Now, when you're at higher altitudes, the pressure of the air is lower than 1 atmosphere. So the vapor pressure equals the pressure of the atmosphere sooner. So it takes less energy because we need fewer moles of our gas to get the vapor pressure to be equal to the pressure of the air. So the boiling point will be lower than normal. Now, at low elevations, it's higher. So if you look at this graph, you see that we have an inverse or indirect relationship between our boiling point and the altitude. So as altitude increases, boiling point decreases. Now, example here, the normal boiling point of water is something you should memorize. It's 100 degrees Celsius. When you get as high as Mount Everest, which is over 29,000 feet above sea level, the boiling point is down to 70 degrees Celsius. So now, if you're trying to cook spaghetti, you're going to be cooking much longer because you're cooking the spaghetti at a lower temperature. Now, it takes less time to boil, but that's because it's boiling at a lower temperature. And so your spaghetti or pasta or rice or whatever would take longer to cook. Now, remember, this affects only gases. So what would happen if we were talking about an oven and higher elevation? What if the oven is set to the same temperature? Well, then it becomes really complicated. And really, it's only going to impact baking that involves gases, which, any type of baking that you do that maybe requires a sauce to boil while it's cooking. Or maybe if you're talking about a cake or cookies that have to rise. Well, when you rise, you're forming a gas. And if that gas evaporates too quickly, what can happen is it'll rise too quickly and that actually it'll be unstable. You won't have any solid baked cake to sustain that gas, and it'll collapse. And so baking really requires some careful adjustments of your liquids and your solids and your temperatures in order to bake something when you are not at sea level. So now we will come back to this at a later time. So until then, this is signing off.